Good morning, students. So now this is under logarithmic differentiation only. Now we will see, because whatever the problem we have solved till now, the base of the log was e. So now the question remains here, what if we encounter a logarithmic function where the base is other than e? So in this case we need to go with change of base. Suppose say the base of the log is not e, it is other than e, then log a of x will be, when you use a change of base formula, I can write this one as a log to the base e of x. First write this x divided by log to the base e of, then you write this base as, yeah, okay? So see this, let me go with this question, then you will understand. Here let me go with change of base. Here you can see base is not e, you cannot differentiate directly. Double log cos x 1 by cos x, no, that won't work. Because base is not e, only the differentiation of log to the base e of x is 1 by x, not other than e. So what I can do here is, let me apply the change of base. Now, if you want to change this base, which is right now is 2 to e, then I can write this one as a log to the base e of, first you write cos x, divided by log to the base e of, then comes this 2. Now this log to the base e of 2 is completely a constant, okay? Then we have, here it is, okay, so why we have here it is log to the base e of cos x divided by log to the base e of 2, okay? So when you differentiate now, dy by dx, keep this constant as it is, do not do anything with this base, yeah, constant, log to the base e of 2, differentiate log cos x, use it, 1 by, what's the double log cos x, 1 by cos x, then differentiate cos x, we have negative sin x. Is that okay? So which is again equivalent to negative sin x by cos. What is sin by cos? Oh, before that one. If you want, I can bring this log up. There is no problem. There's a two method to bring this log up. Either you interchange the base. If I need to bring this one up, I can write this one as a log to the base 2 of e. Which means here I am interchanging the base. Okay? So if you want to bring this log up, you have to interchange the base. Then sin x by cos x is negative tan x. This will be the answer. So let's go with Roman number 2. Now here base is not e. I can use change of base. We have log to the base e of this. Please use the change of base formula. We have, this is there in class 11 as well, okay? So I can write this one as a log to the base e of sin x, first write this one, then divided by log to the base e of x squared. That is as per the change of base formula. Then let me rewrite once more. This can be written as log e of sin x divided by, I can write this one as a 2 log to the base e of x. This is in the form of m raised to n. I can bring this 2 in front. So now both are the function. Then we can go with the quotient rule. This is nothing but y. That implies dy by dx is equivalent to 1 by 2 is a constant. Keep this one as it is. Then please use quotient rule now. Here log to the base e of x, it becomes whole square. Quotient rule, u by v method. Then log to the base e of x remains same. When you write little bit above. Understood now? Because when you differentiate this function, you know you will get in denominator. So what's a log sin x? It is 1 by sin x times difference of sin x is cos x. Actually, no need to write every time this way. You can write directly. You know log sin x is 1 by sin x, difference sin x is cos x, cos by sin x, you can directly write cot x if you want. But let's go with this way right now. Minus. Now you keep this one as it is. Log of sin x. But differentiate this log x. 1 over x. This is okay now? So, one by 2 is a constant. Keep this one as it is. Now, what is cos by sin? It is cot x. Cot x times log to the base e of x. Then minus we have log to the base e of sin x divided by x times whole divided by, oh Lord, make sure when you write, this should be now whole divided by, what we have here, log to the base of x whole square. Close this bracket for this 1 by 2. Now let me do LCM. Please do LCM. X is multiplied here, okay, please do LCM. We have final answer. Please do LCM. We have x cot x times log x minus 1 into this one, the same thing, log of sin x divided by, you know, this x becomes a common denominator. When it becomes common, definitely it will come in here, right? So this becomes, don't forget this 2x log to the base of x whole square. This is a simplified form, okay? So this question now, Roman number 3. Here the base of the log also is 7, here also is 7, but not the base e. What I can do here is, let me use the chain rule, okay? In chain rule differentiation, for that what I can do, let u is equal to, take this one as a u is equal to log to the base 7 of x, and definitely y will become now log to the base 7 of, since I have taken this one as a u, this becomes log 7 of u. Under chain rule, now what we can see is u depends on x and y is depending on u, which means you have to, if there's any change in x, there will be change in u. If there's any change in u, there will be change in y. So therefore, you will differentiate u with respect to x. This case you will differentiate y with respect to u. This is the way to go with the chain rule differentiation. Okay. So now, before differentiating, again, base is not e. You cannot differentiate directly. What I can do here, use change of base formula. This will be log to the base of x divided by log to the base of 7. This is nothing but u. Now we can differentiate du by dx is equal to 1 by log of 7 is a constant. Keep this one as it is. What's the differentiation of log x? 1 by x. Right. Similarly, this side, base is 7. Apply change of base. I can write this one as a log to the base of u divided by log to the base of 7. This is nothing but y. Now differentiate y with respect to u, because y is depending on u, not x here. Okay. So 1 by log of 7 is constant. Keep this one as it is. What's the differentiation of log u? It will be 1 by u. I hope you got it. So now, finally, what we need here is, okay, let me substitute u, which is equal to 1 by, actually what is u? This is the 1, right? So substitute here, this becomes log to the base 7 of x times log to the base e of 7. So what is the final answer we need? We don't need du by dx, we need to find dy by dx. That is our main job here. Our main job is to calculate dy by dx. So how to get dy by dx? It's very simple here. This will be dy by du times du by dx. That correct? Right. This du will get cancelled. So you are getting dy by dx. Which is equivalent to, what's the dy by du? This is the one. Right. This is the dy by du. So substitute here. We have 1 by log to the base 7 of x times log to the base e of 7. Then substitute du by dx. This is the one. 1 divided by x log to the base e of 7. So now the final answer we can write here it is 1 divided by x. You keep this one as it is. Log e of 7. Log e of 7 becomes log e of 7 whole square. Right. Then at last we have log to the base 7 of x. So this will be the final answer. So let me go with one final question under logarithmic differentiation. So after I complete this question, then in next video lesson we will start with exponential differentiation. Once I complete with this, make sure you go with homework number 6. chapter 5, page number 23, exercise 5D, question number 23 and question number 27. So let me go with this question now. We have f of x is equivalent to log to the base of x squared times log x. You need to prove that f dash of e is equal to 1 by 2e. For that, before going with this one, here, this is a proving question. We need to go with the change of base. Base is not e. Did you see here? Okay. So I can write this one as now. Log to the base here log x divided by log to the base here this x squared. This is the way to go with change of base. Right. So let me rewrite once more. This can be written as log to the base here of log x divided by 2 log x. This is in the form of log m raised to n. You bring this 2 in front. So we have y. What we can do here is, we can go with the quotient rule. Right, this also is a function, this also is a function. So let me go with quotient rule. That implies dy by dx is equal to 1 by 2 is a constant. You keep it outside. Then, it's a v quotient rule. V square, which is log x whole square. Keep this v here. But differentiate you. When you write little bit above. You know this answer will come in denominator. Log of log x is 1 by log x. Again differentiate log x. This becomes 1 by x. Minus, keep this one as it is. Log e of log x. Now differentiate this log x. We have now 1 by x. Simple as that. This log x and this log x will get cancelled. So here in numerator, now what is common? 1 by x is common, isn't it? So since 1 by x is common, okay. Check that 1 by x common outside. We have 1 by 2x, and if I take 1 by x common outside, what I'm left now? 1 minus log to the base here of log x divided by, this is log x whole square. This is nothing but f dash of x. Is that okay? That implies, now we need to prove that the input value of x should be e. Then we need to prove that is equal to 1 by 2e. For that, so f dash of, substitute in place of x, substitute e is equivalent to 1 by 2e. In place of x, substitute all e. Now 1 minus log to the base e of, this one is log to the base e of, in place of x substitute e, right, divided by log to the base e of e whole square. Just substitute e in place of x. Simple as that one. Now, as per the logarithm law, what's a log to the base e of e? 1. Right. What's the log to the base e of e? It turns to 1, which is equivalent to 1 by 2e. Then we have 1 minus log to the base e of 1 divided, this is 1 square, this 1, more it. Right. So what's a log to the base e of 1? It is equivalent to 0. It turns to 0. Which means we have here 1, which is 1 by 2e. Hence, proof. So logarithmic differentiation is over. So in next video lesson, we will start with exponential differentiation.